Right, welcome. Welcome to our session about DevOps, about technology and about people. Okay, that's the deal today. Grand title, but technology and people is the kind of concepts behind DevOps. So hopefully a few of you came to our talk a couple of years ago. Quick show of hands, who's come to our talk before? DevOps? Oh, about 5%, maybe a bit less, that's fair enough. So we talked 2 years ago at Devoxx about DevOps. It's called moving to DevOps mode. Now, pretty much the industry has come along with that kind of stuff. DevOps is a normal thing these days, probably slightly even overhyped. But we talked about DevOps being sort of an extension of agility from the dev team pushing down into ops. It's all about breaking down silos, but it was about people, culture, organization as much as it is technology. Today we're going to look at microservices, super hot topic obviously, and the sort of their relation to cloud and containers. We're going to look at the platforms they sit on and sort of implications for that security, networking, Steve's field, like a lot of interesting insight into that kind of thing. But fundamentally, DevOps as a concept is still all about driving change, innovation. It's about the organization, it's about the people, it's about the processes and the technology. So this is us. I'm Daniel. I work for a consultancy, so I get to see lots of interesting problems, and I go to a lot of conferences as well, so I get to see lots of interesting solutions. So hopefully I'll share with you some of my war stories, some of my learnings from conferences today as well.
Yeah, I'm Steve Poole. I work for IBM, and I wish I was BizDev QA Ops. That's really cool. I'm long-term Java developer, though for the last couple of years I've just been doing DevOps, and I'm building, with the team I have, a lot of DevOps capability for IBM development teams, because we're applying these principles that we're talking about for the products that we're building and the tooling on top of that.
So I think, Steve, this is yours.
Oh, I start. Okay, so microservices and painful lessons. You go talk to development teams, or you go talk to application developers, and they go, microservices. All I hear is microservices, and it's just a fad, and it's like this. It's stuff. I read about it, but it doesn't mean anything to me. Why should I do this? Right? What you're asking me to do is take my existing application and break it into small, wafer-thin pieces. Why would I do that? Right? You want to make my life more complicated? I've got a system already and it works fine. Why would I want to do this breaking up into pieces? Right? I have my server and it runs all the applications that I want. What's wrong with that? The trouble is, when you look at it in detail, your system looks a bit more like this, and that you have a wonderful little server, and sitting on top of that is all your different applications. And you don't really take a good look at it until things start to go wrong. So, what's the problem? How many people have got a system, would consider that they've got systems like that? I know I have.
It wants to admit it.
Yeah, okay. So let's decompose this into some diagrams. So I'm going to go through what happens. I mean, very simplistic. So here's your data center, and here are your customers, and let's assume they get your systems through browsers, all very simple stuff. And there's you, and you have a little server, and you have a database on it, and you have your application. Easy. We've all got one of those. They're great. They're no problem at all. And then maybe it gets a little bit more complicated. Maybe you've got another application. You can see application B turns up. And you go, I'm going to put it on another server. And you go, well, it's got its own database, but the database that I've got for the other application, I want to access some of the tables because that's where the data is, and we start making database calls, and it gets a little bit welded together, right? And you go, this is really good, and then it gets more successful. You get more customers, and you have more browsers, and your load balancer, which you've put in, starts to work harder, and you start to scale up more applications. Maybe you don't put the databases. Maybe you just have a server you just go out and buy another server and you connect it up. And this is you down here, right? You're now into I'm trying to keep this system up and running. It's taking time and effort. It's getting a little bit clunky. And then something really, really exciting happens. You become very successful. You get more customers. And your business goes, we need to buy more kit. But I understood you should put it on the cloud. Go cloud bursting. Start putting your stuff in the cloud. So now you've got load balancers in different places. You've got whole application copied, and that's what we do. We go, take that thing, put it in the cloud, and keep the original. Let's wire it up. We've got networking. We've got all sorts of crap coming together. And we're spending our time going, how do we get here? And what can we do to fix it? And everybody's going, you can't change it. It's just horrible. Just live with it. Right? And then the best thing that happens is somebody says, we need to upgrade it. We've got a new version of this app. Can you just roll it out? Just upgrade it. Right? And if it was just changing the app, you might just get away with it. But what tends to happen is that you get a schema update as well. Okay, and then you find that some of your other applications that are using it, which you may not have known about, crash, die, right? So the question is, if you're in this situation and it went wrong, is a simple upgrade, is it a simple upgrade for you, or is it a major impact? Right? Is it lost revenue because it's down a little bit, or you got out of business? The figures say that if you have an application on the cloud and it's down for, I think it's a week. If you are unable to respond to your customers for a week, you are out of business, right? And that's the sort of things we're getting. So what lessons have we learned here, right? This is a big impact. There's lots of impact to your application, to your business. What have we learned, right? So the first thing we learned was tying things together is a bad idea, and tying them together at the database level brings a bunch of cohesion that you don't want. We really don't want to do that anymore, right? Begin to sound a bit like microservices, isn't it? Start to cut things at a different layer, right? We know that if you're going to do big bang versioning, right, which you could do, you're going to change a bunch of stuff that's going to impact other use cases that are using it. So you're versioning something to get a little bit of an update, but basically you could be changing your whole system and impact all the other things. A bad thing. Maybe you can see when microservices starts to come in there, right? And if you try and scale by taking your whole system, again, very bad, right? It's just the wrong way to go. We don't want to do that anymore. Right? What we're basically learning is infrastructure and the software that you put on top of that, the virtualization layers, containers, etc., they're really, really important. We've learned that a lot. But what we've also learned out of this is microservices, the design has a really good reason for existing. It helps us not get into these sorts of problems. And with that, I'll hand over to
me. Thanks, Steve.
Daniel's going to do how to build one.
Yeah. So riffing off what Steve was saying there in terms of infrastructure being super important, in my sort of day job as a consultant, I totally agree. A lot of people are starting to build their own microservice platform now. Cloud, containers, all that kind of goodness. So we'll need to think, what is a microservice platform? What do I need? And this, for me, is great. Adrian Cockcroft from Netflix, Sun, eBay, he's at Battery Ventures now. He talks this as being sort of, your bare bones platform. Application support at the top there, tooling config, and you've got your, for want of a better word, fabric below there, your platform fabric. Data stores, orchestration, containers, that kind of thing. The only snag we've got at the moment is wherever there's a kind of proliferation of ideas, a proliferation of technology follows. Yeah, this is actually, it's not my work, this is from Wikibon, and it's over a year old now. But look at the choice I've got when I implement a platform. Yeah, it's really confusing. As a consultant, I get to, this is part of my job, but clients I work with, they're almost overwhelmed. Even Amazon alone, for example, and AWS is a fantastic platform, but you look at what AWS offers, and it's bewildering. I need some of this, I need some of that, how do I put it together? That kind of thing. A lot of people are writing their own paths effectively. Wherever you start in the stack, if you're on Kubernetes even, people writing paths on top, you start finding yourself, this is from Colin, a friend of mine, Hat of Monkeys on Twitter, it's a bit of a tongue-in-cheek thing, but it's basically saying, I started to write my own scheduler. It looks like you're trying to build your own platform. Why don't you use, in this case, Cloud Foundry? But there's other paths available as well. The snag is we are all building our own paths, but what's wrong with the current solutions out there? Just a little thinking point. As a developer, I think these are the critical things I need to be thinking about. A kind of DevOps-savvy developer, continuous deployment, how do I get my code and my colleagues' code through a pipeline, proving its health, deploying it into production. How do I need to be sort of have some mechanical sympathy, should we say. I need to understand the platform. I need to echo that back in terms of health checks. Is my infrastructure okay? Are my applications okay? Is the business okay? all through metrics and so forth. And that kind of riffs nicely onto logging and monitoring as well. Now, I'm not going to talk too much about continuous deployment and health checks. I did a talk actually last year at Java 1, so you can check that. I'll share the slide deck. You can check a link there, and it's on YouTube and stuff. But just a couple of brain dump slides. This is the approach I take with logging. Logging is really good for after-the-fact analysis. Like Steve showed there, things go wrong or whatever. Logging captures every event in your system. Yeah, so you can look back, you can comb through logs, understand what's gone on. A couple of great links here for sort of understanding how to log, particularly in Java. It's an art form. I've seen many bad logging statements, literally logging everything. I'm connecting to the database, I've got a record. And I've seen some that's just literally application's good, application's bad. You know, there's a nice happy medium there somewhere. I like the ELK stack, Elasticsearch, Logstash, Kibana. Great for sort of container stuff. If you are using containers, cloud things, do mount directories sort of into the container rather than logging directly into the container. I'll tell you why a little bit later, but that's a key thing. Monitoring is great for sort of near real-time views on your application. I'm a big fan of Grafana, and there's something called the tick stack at the moment, which is interesting. So you can push data, and I use Spring Boot a lot. I also use things like CodaHail Metrics library. You can push it, say, using InfluxDB exporter. Have a Google for that one. Increasingly, though, we're generating so much data that if you're pushing it all, it actually saturates networks and things like that. So the Poole model is becoming more popular. I reach in, get data, things like the tick stack, which is Telegraph, Influx, Chronograph, and I can't remember what the other one's called now. But they're really good. Prometheus the same. And you can actually be, say, pulling in data every 10 seconds, whatever you like. If you think you've got an issue, you can ramp up the times. You can basically be pulling in every second, every half second. The Poole model gives you control of the data flow. Quite nice. There's a blog post there about sort of comparing some of the options. Have a look at that one. And the key thing is you need to be radiating this information out to your developers, your ops team, your QA, your business. And you do need to have a think about kind of the aggregate versus the individual metrics. So there's a bit of a joke at the moment. We sort of say, think about servers, think about containers, think about applications as cattle, not pets. Back in the day, we built servers, we named them, and we looked after them. Same with applications. Now, cloud, it's volatile, it's ephemeral, it's transient. Things come and go, so you really want to think of them as cattle. If they do get sick, you can kind of put them to the side or not worry about them as much as, say, you would a pet. The only snag with this is often people get stuck in the aggregated view. I saw a great talk yesterday by, it was Andrew and Kevin, I think it was, talking about sort of percentiles, things like that. And it's really important. Yes, have a look at the aggregate view, but also be mindful of your percentiles. What's the 95th percentile look like? What's the 99th percentile look like? Are some part of your user base having a really bad experience? The mean, the average, doesn't give you much, in all honesty. You can have massive different variations, massive statistical variations. Think about the aggregation, but think about the individual level as well. Distributed tracing, super important in microservices. Now, if something comes in, ingress, it often gets fanned out, it goes to multiple services. You need to be able to stitch those things together. Correlation ID, super interesting. MDC logging, adding more data to your logging in terms of what servers are responding, what threads are responding. So you can therefore basically knit together the complete picture of how this request was solved in a microservice architecture. Comes in, gets threaded out, hits multiple data stores, third parties. If you pass a correlation ID through all of those and log them, you can stitch together the path through the system after the fact, which is very nice. Zipkin is freaking awesome for this. It came from Twitter. So if you've used like Firebug, things like that on the front end, it gives you a nice picture of how things were basically been solved, how requests have been served, in the application, and what was involved in things. So Steve and I did a talk actually at Java 1 last year about Docker and Java. So I'm very quickly going to give you a few tips because we mentioned cloud and containers in the title. Looking inside the container, these are the kind of common issues I see with Java and Docker. People constantly running out of log space is a classic. So please do move logs to a mount, because if you actually fill up the disk, say that the Docker daemon is running on, sometimes the Docker daemon will freeze, and then all bets are off. So anything you're going to be chucking loads of logs, move it to a mount point, move it to a separate disk. People at the moment are kind of restricting resources, which is a great idea, but they're restricting memory when they're using a JVM only to XMX. So they're running a 2 gig heap, and they're saying, this is my Docker limit, 2 gigs. But in reality, you need the heap, You need metaspace or permgen if you're pre-Java 8, and you need a bit of overhead for JVM. You actually need a bit of overhead for each thread you're going to be spinning off, because the threads kind of have an overhead with them as well. There's a lot of security and crypto issues, very subtle issues I'm seeing. Dev random is a bit sort of limited on containers due to the entropy involved, running multiple kind of OSs, multiple containers. So I often see things like Spring Boot booting up and it will freeze, or you go and create a new session on the website and the app will freeze, and that's because dev random is blocking. If it hasn't got enough entropy, it will block on a request until it can generate more randomness. So you can get over this by passing a parameter into your Java app, specifying urandom, which is pseudo-random. So if you see lots of weird things, you're debugging them, and you see it's blocking or freezing on security or crypto issues, and you're running Docker, this might be your problem. Catches a lot of people. Chris is doing a talk in here later. Do come along. If you're interested in Java and Docker, Chris has got some great sort of insight into this. So 3 o'clock in this room today, check out Chris's stuff. These are really just brain dumps. These are some great blog posts I use quite a bit. If you're looking to sort of debug the actual, let's say, Java or the OS itself. A little heads up, if you're looking at the OS stuff, things like the proc file system, which we use quite a lot in containers, some of the things are not C-group aware. And C-group is basically the notion of sort of your control groups in containers. So you can be looking at things like meminfo and vmstat, and they're not aware of containers. So you won't get an accurate picture of what the actual data is on the file system. So you need to use things like sysdig. Sysdig is a really awesome tool. It's container aware. You can run it. You can get a really good overview of what's going on at the OS level. A couple of sort of brain dumps on problems. This book has been really helpful in my journey into the kind of DevOps thing. I really like sort of Rob's philosophy on alerting. Like alerting itself is an art. When do you wake someone up at in the night? And Brendan Greggs from Netflix has got this great method called use method, which is utilization, saturation, and errors. If I'm debugging things now, I naturally and it's in production, and the alarms are going off, I often use Greg's method there. So Brendan Greggs' method. It's really good. I think that point I hand over to Steve.
Oh, thank you. Let's go back. So, okay. So I said we have to go towards a microservice architecture because it's the right thing to give us the scaling and the availability of our new systems. And then Daniel went, here's how you build one, and here's all the stuff you need to know, right? So the question is, are we any better off, right? Are we asking you to swap one for the other? Are you, as it says, is the glass half empty or half full? What have we got? Right. So it is scary. So I'm going to little block diagram here. So we have a lot of good stuff, right? One of the things that happened since we started, the first time we did this sort of talk, was things have matured. And Daniel's talked to you a lot of bits and pieces, but they're all starting to come together. So we've got, basic layers. So we already know we've got cloud providers, you've got good handle on OSs, you can have VMs, you can have Docker Cloud, you can use OpenStack. There's lots of nice layers. The way that you construct those VMs, those Docker containers is well articulated. There's a whole bunch of infrastructure as code tools you can use to create them. You can build Docker images, you can build VMs. There's all sorts of, but the tools there. Right, lots of choice, but they're starting to come together in their places. We've got deployment tools. How do we actually get these things out? Again, that's coming through. We've got tools for deploying. We have tools for keeping things up and running. So if your system starts to get a bit sick, you can spot that, and you have systems that automatically recover and spin up new ones and deal with your demand. So that's cool. Those things are happening. We've got good pipelines. We've got Git and Jenkins. There are people offering services to line this stuff together. So you as a developer have a lot of new things to learn for sure, but it's coming together. The key bit is you're the one that has to learn all this stuff because this is DevOps and self-service. So really, you've got a bunch of tools, and so your job, all you've got to do is now the bit at the top, isn't it? Just the application. You have to do anything else. Well, yeah. So there are two things. First off, you could make use of this technology, and you can dive into that, and that's obviously the right thing to do for the long term. And you can listen to more people like Daniel tell you how to do some of these details. Or you can keep building it yourself, right? So you could go off and try and replicate all this and then try and end up with the same situation, which is probably not the right thing to do. But again, it's still down to you. Now, there's one other little bit in here that doesn't really come up very much in these conversations, and that's that little layer there, compliance and security. Right. So in this new world, where you are the developer, and as a developer and building these solutions, and the guys providing these services, you don't talk to them because they're providing you a service. You have to do things. So those VM images that you're going to create, or those containers, they have to be secure. So you have to learn how to do security, right? You have to be compliant to whatever compliance rules you follow, right? And they're quite wide-ranging. So that's now your problem. Oh, and because this is going to be running in the cloud, that firewall, that networking access to that system, to your system, that's your problem too, right? You know all about that, don't you? You've all done security and compliance, and you know all about that, yeah? Probably not. I mean, the talk before this one was very interesting about security compliance. It's the biggest new thing out of all this stuff from a developer's point of view in DevOps is you've got to get your head around this stuff. It really is the important because you're the ones on the hook. Right. So where's your data? That's a good question. When you put stuff in the cloud, you do understand that your data's in the cloud. Right. What you find is if you go talk to your ops guys, they'll tell you, there are rules about where data can go. In fact, your business will be able to tell you. Right. In Europe, there's a whole bunch of rules as to whether your data can be in this country or in this country, depending on data and local rules. That's your problem, because you're deploying to the cloud, so you've got to deal with that. Right. It's really scary. And I think where it was. I think it was Poland, where they were saying, if we don't get it right, we go to jail. So for some people, it's quite serious, right? So you need to know that. You need to understand how these systems are controlled and managed, and it's now your problem. The whole thing about this DevOps stuff is it's coming down to you to do, right? And do you think the tools out there to help you do data management in this way? No. So again, how's your security knowledge, right? It's your problem. You have to build secure systems. You're the ones building it. You're the ones deploying it, and so you've got to look after it, right? Are they secure? Do you test them? How many people routinely write tests for the security of their application, and not just positive tests, negative tests? Prove that you can't get in. Prove that if certain types of hack take place. You've got to do those now, right? What about networking? How good are you at building complex network architectures? Right? Chances are not very good, right? And what about cybercrime? Okay, I've got to ask this. This is me just being vain. How many people came to my cyber security talk? Cool. Okay, excellent. So you'll see this side then. When we did this talk 2 years ago, which is scary. Yeah. This slide was totally different. This slide talked about hackers and people getting into your system for the fun of it and breaking things. That is all gone. The big takeaway for security and cybercrime right now is it's the biggest growing criminal activity it has, and it's currently roughly about the same value to the criminal as the drug business, but it's going to outstrip that, right? And one of the reasons it's going to outstrip it is because it's so easy and the risk is so low, right? So you've got to deal with this as well. You've got to understand that you've got a new environment, a whole bunch of new tools. You've got to learn about networking, got around security, and guess what? The guys that we're up against have got better and are more organised and are going to be targeting you. And as the guy before this on the talk here was saying, you're going to get targeted. Somebody's going to come and knock at your door. Right? So overall, we suggest the best thing you can do is go talk to your ops guys. They don't have all the answers, but they have a lot more answers. You have to engage them. And what you'll find in many organisations, like my organisation and others, is our relationship with the ops teams is reforming because we're trying to get their knowledge baked into the VMs and the tools. We don't want to engage them 100% because that's not fast enough, but they're the guys who know the answers, and you need to pull those in. Right? So let's talk about how we do that.
Cool. Over to me.
Yeah.
So Steve's kind of set the scene there. Like, and I see this quite a lot with my clients. Like, it might sound a bit grim, but in some respects, it kind of is, Steve, isn't it, in terms of what we're seeing? It is only a matter of time before big businesses get hacked. Now, I can't mention clients' names, but some big clients we work with, they're getting hacked on a daily, hourly basis, pretty much. Yeah. So if you become popular, you will at some point get hacked. It's as simple as that. But trying to lift it back up a little bit, sharing is caring. This is important. So there's a great survey done by the Puppet Labs people. Nicole Forsgren and Jez Humble have talked about this. They've got a couple of great talks called Sciencing the Crap Out of DevOps and that kind of stuff. They tried their best to make the surveys as statistically valid, or the results, as statistically valid as they could. So Nicole, PhD in statistics, and done some fantastic kind of working of the data. I'm inclined to believe it. They are sort of very reputable people. This DevOps thing, whatever we call DevOps, is super valuable. It accelerates deployment, and it prevents failures and streamlines recoveries. Now, this for a business is like gold dust, unicorn food. This is great. The snag, as Steve's saying, is like, how do we actually make DevOps a reality? Well, I get to see lots of interesting attempts at implementing DevOps in companies. Now, Matthew Skelton, a guy I know from London, he runs the London Continuous Delivery Meetup group, has got this great page called DevOps Topologies, and he's categorized some anti-patterns he sees, and I totally agree with them. There's a classic there. You've got the DevOps team. DevOps team? Like it's Dev and Ops, yeah? You've got the devs don't need ops, so there's a big gap there, and they've got DevOps embedded. We've got DevOps as a tooling function. It's a great website. Check it out. You'll probably recognize some of the patterns. I certainly do from my day jobs. But it's a nice way to categorize it. Once we've got that kind of shared language, that ubiquitous language, we can have a discussion. I think as a company, we're doing this. How can we fix it? And that leads nicely on to the second part of Matthew's topologies, the good bits. The classic proper dev plus ops, shared ops, ops as IaaS, kind of providing services. I've spelled it wrong, apologies, but meant to be temp DevOps team is a popular pattern, kind of transitionary DevOps team. And then I'm sure a few of you have heard about the SRE, Site Reliability Engineering. Google are talking about that quite a bit. Has everyone heard of SRE? Sort of over in the US, it's like super popular, so conferences I go to there, loads of it. It's becoming more of a thing. There's a great book, actually, by the Google engineers called Site Reliability Engineering, O'Reilly book. Check it out. It's really good. And it talks about this kind of pattern, which is what I'm seeing the most success with. And you have your dev, you have your ops. Like some companies I work with, like Steve said, the ops people are super talented in, say, SANs or network attack storage or security or whatever. We've got our specialities, but there's this notion of sort of DevOps here and then an SRE team who are responsible for latency and performance, these kind of things. I won't go too much into the details, but it's an interesting model as kind of like, it's the most complete I've seen in terms of the true DevOps ideal of we all have shared understanding and shared accountability, shared responsibility. I like this a lot. Great website, check it out. I'm going to talk a little bit about the spine model as well, because I only stumbled across this recently, to be honest, so I'm still getting my head around it, but it's a great model. It's all about effective conversations making for effective collaboration. We see a lot of people getting stuck in the DevOps world on tooling, and they get this kind of dilemma where there's equally plausible options available. I showed you that whole list of technology, and it's like, I want to use Docker, I want to use Rocket, and they just cannot break the deadlock. Whereas the model, the kind of spine model, allows you to break the deadlock by going up the stack. So we are, as a species, very much in love with tools. Arguably, it's what separates us from the rest of the population, the animal population. And we've always been tool users and tool makers. We use X to get work done. But if you get stuck, you can step up through this hierarchy, practices before tools, principles before practices, values before principles, and needs before values. Sounds kind of like a lot of things I've been reading in the literature recently, even a bit Agile Manifesto-like. The Agile Manifesto had its principles as well as the Agile Manifesto. Principles and things like values are really valuable once we start peeling back the layers. Well, why do we want Docker? Because we want this practice, hermetic deployments. Well, principles are we always run things secured. Well, Docker, we've got to run the daemon as root. That's not so good. Maybe Rocket's best for us. That kind of thing, yeah? Think about, all too often, I think we as technologists, I'm totally guilty here, get stuck in the tooling without realizing what we're actually trying to, what need we're addressing. Yeah. So this, for me, is a really valuable model. It was, they talked about it a couple of years ago, I think, or 2015 maybe, at Agile 2015. So there's a YouTube video online, and I've linked to the actual wiki there as well. So it's really good to think about these things. So things inevitably go wrong when you deployed stuff, and people are always involved in the mix, yeah? And when it does go wrong, you want to be this person, yeah? You want to be kicking back with a beer, knowing what's going on, basically. So I'll just check my time here. So I found this model.
We've got loads.
We've got loads. Oh, awesome.
Yeah.
So this model really useful. So the Google people have actually adopted this now. It's in the Site Reliability Engineering book, but I bumped into it. Nori Heikkinen talked about it last year at QCon New York. And she talked about that this is an awesome kind of hierarchy of needs, much like Maslow's hierarchy of needs. Yeah. So I'll talk about where it comes from. So healthcare.gov. I'm sure a few of you have heard about healthcare.gov. In the US, they don't have the NHS, so they have to buy healthcare insurance. And President Obama made a big thing about making it easier and making it more sort of reliable and so forth across the whole nation. So they put it out to tender. Healthcare.gov was delivered, and it fell over straight away. Like, it's fundamentally like a website where you log on, you give some data, and then it recommends policies for you. Not rocket science, if we're all honest, but quite big scale across the whole US. But it was deployed, fell over, and it took them over a month to get it back up and working. And the story is because 50 independent contractor companies were involved in this. No one took responsibility for things. Things fell over. All they were doing was finger pointing. Yeah, no one was actually solving problems. So President Obama was like, this is like so important to me. I've got to fix it. So they brought in a crack team of people. They went to Amazon. They went to Google. They went to lots of interesting companies and assembled this crack squad. Nori was one of them. She's talked about this quite a lot. Mikey Dickerson was also one of these people. And they came in, basically they, over the course of like 6 weeks or however long it took, managed to stand the application up and get it working. Now, one of the funny things is Mikey walked in apparently on the first day. The site was constantly crashing, coming back up, crashing. And he was like, this is bad. Like, went into the development team and said, how do you guys know when things are going wrong? And they pointed to a monitor in the corner of the room. And Mikey was like, awesome. They're going to have Nagios or some kind of metrics on a monitor. Actually, the monitor was a TV with CNN on. And when it got reported, they'd be like, oh my God, reboot the database, yeah? Crazy, yeah, kind of stuff. And there was people running queries. Managers were asking them to run queries, and they run queries, and they bring down, because it was one database, the whole site. But no one would admit they were doing that because of the toxic fear, toxic culture. Like very much what Maz talked about in the keynote. So what I'm trying to say here is fundamentally you need to think about basics. You need to have monitoring. You need to have an awareness of your systems. That's kind of the DevOps thing. I need to work as a developer with my ops team to understand what I should expose to allow us to make good decisions, both at a OS level, a hardware level, an application level, and a business level as well. Yeah. But after that, it's all about the people. Incident response. Do you run around screaming when things are going wrong? I've literally seen that in companies, yeah? People, not good, to be honest, yeah? So you need to think about these things. So Google are doing this, they call it DIRT sessions, disaster in recovery training. Other people call them game day sessions. But they have deliberate time where they go into the data center, real-life chaos monkey, they start pulling out cables, physical cables, yeah? Now, apparently, if it goes wrong, they plug them back in really quickly. But in terms of, it mustn't cause massive customer impact, but it does allow them to see what actually happens. Who gets paged? How do they respond? What does that person do? So game days, actually simulating failure are a very valuable technique in the DevOps world. Running honest and blameless postmortems, super valuable. Again, healthcare.gov, no one was there was lots of finger pointing, but no one was actually taking responsibility. But Etsy do a lot of write-up around this, really, really good. So check out Etsy. John Olsford does a lot of cool writing around this. But this kind of optimizing for learning, optimizing for feedback in the DevOps world, super important across the whole team, yeah? Whatever you want to call it, DevOps, SRE, whatever. It's really important, learning and feedback. So conclusions. I think this is both you and I, Steve. We're going to wrap on this one, aren't we?
You start.
Cool.
I can't remember.
We've got bags of time, haven't we?
Yeah.
This is all good. So key messages. Key message, really, like Steve sort of mentioned this, is microservices force you to know about distributed systems. Yeah, they really do change the way you think about things, both at a sort of infrastructure level, but at an application level. Like Steve was showing there, things are going wrong, where they're going wrong, how do I debug it, that kind of thing. Steve,
so whether or not you look at microservices as a fad, and whether you go, I don't believe that I need to do my application design that way, if you look at it from the availability and the scalability, it makes perfect sense. Right? So the argument is why you should use microservices. It's because it will give you a scalable, more secure service because you're dealing with it the right way. And it's going to be more available. And at the end of the day, what we're trying to build here is highly available solutions. Yeah.
Definitely. I'm seeing this, a lot of clients I'm working with at the moment, we're teaching them to think about domain-driven design. So if you haven't sort of looked at domain-driven design, it is really valuable. Taking a step back, we're all as technologists, too tempted, I think, at times to dive into the technology. I'll buy a framework to solve my microservice issues. But again, like the spine model, look at the principles. Why are you trying to break up your app? Like Steve was saying, it's often because of performance issues or scalability issues. Microservices actually are really good at sort of separating development teams, for example, whereas they can be tricky for scaling things individually. Arguably, you can do that with monoliths anyway. But microservices is really good for allowing you to break up your development.
Well, you don't necessarily take your application and get a sharp knife. Right? What you might do is you take your application and go, the next service I'm going to apply this application, the next thing is going to be microservice. Was it you were talking about strangling applications? Yeah,
so one pattern, we have 3 patterns for deploying microservice solutions. One is the Big Bang, which we generally don't recommend. The second one is kind of pulling things out. And the third one is the strangler pattern. So you put a router on top of your monolith. You've got your monolith. It's basically Twitter, actually came up with this one. Put a router on the top. You have your monolith there, and you build new things on the side. And the router is kind of some people call it an API gateway. You can use an API gateway for this kind of thing, like Kong or Amazon API gateway or API. And so then it intelligently routes traffic. Oh, this is a request that can be purely solved with the new stack. This is a request that needs to go to the old stack. Then maybe it calls out to the new stack as well. So strangling applications is a really powerful pattern to avoid that kind of big bang, oh my God, this is super risky type of thing. So the second thing is the application infrastructure platform is still not fully baked. And one danger I'm seeing is, again, guilty as charged at times, as a technologist, I love playing with things. But with my business hat on, I need to make sure I'm adding value to the business. So should I really be building my own microservice platform? Maybe I should be using Cloud Foundry or Apprenda or Deus, something like that. I see this quite a lot. We go in and help companies that are literally building their own platform. And it's super exciting at the start. Everyone's, I'm playing with all these cool tools, like all HashiCorp tooling. I'm doing, great stuff in Amazon or on AWS. And they get to a certain point where they don't have the knowledge, or they kind of, distributed systems are hard. So really think, do we have the complete knowledge available on our team to build a secure, performant, and reliable stack?
Yeah. And the answer is not yet, because we're seeing secure. So I think my view on this is the application, the technology stuff is pretty good. I mean, you choose which one you use, but I think you pick one. It may not survive forever, but you'll get your head around it. And I think they're all pretty good. I'm quite happy with the basic stuff. But there are extras like health checking, logging and monitoring. So logging, you're going to go, logging, I've got logging. But when you're into a new microservice thing and you've got services that come and go, you need a new approach to logging because your service is dead. And there's some economics around all this space as well that says people don't want to pay to keep broken systems around. We're talking about cattle versus pets. Part of that is, it's a bit sick, so you don't debug it, you just kill it, and then you just run it again. And if it gets sick several times, then you start having to figure out how you're going to debug it. Right? And if you have to debug it where you're paying for it, then you're now clogging up resource. And so you've got to think new ways of debugging your existing problems because the economics have changed, and that's affecting people now. Yeah.
I was going to say, Steve, something I'm seeing quite a bit at the moment, people are really getting into sort of AWS Lambda, serverless style stuff, or Google Cloud Data Functions, and logging there is super important. I think the Lambda style functions are almost a bit like, say, database stored procedures with triggers. Can be really hard to debug at times. So if you are looking at serverless, it's a total kind of buzz at the moment. It's super interesting, I'm not going to lie. We've done some really funky stuff with serverless, but be really careful in terms of this very small, nano service, whatever you call it. How do you know it's being triggered, and how does it fit into the overarching system is very interesting, very challenging at times. Yeah. I think as an industry, we have this massive swing. We go for sort of highly coupled and operationally simple approaches, and then we swing to loosely coupled, operationally complex systems. And the moment we're on the swing up there to microservices, like I can, as a developer, I can understand a microservice, it fits in my head quite well. Operationally, it's more challenging. A monolith, where they were highly coupled systems and operationally simple, I'm trivializing, obviously, in terms of operationality, but I build a monolith and I deploy it. It's not too hard to operationalize. But the complexity is in the monolith. I have to fit all the code in my head. And unless I've got a very strong, a very good architecture, and it's very difficult, and arguably when you get a certain size of code base, it's impossible. As a human, I cannot fit in all the knowledge I need to understand the architecture of that one thing. But then when I split it out into microservices, it becomes operationally more complex. Guarantee now we're swinging back the other way. We'll go back to perhaps I heard Chris actually say earlier on, medium services, like in the middle kind of thing. And we might be seeing more things like Kafka and Apache Beam for doing data processing. There'll be more separation of concerns versus kind of these things. But do think about the operational complexity.
Yeah. So we didn't say anything really about CI versus CD. So that's another drive. So microservice architecture and all these wonderful things to get you a scalable system. The other thing is, you are probably already getting it, is that the businesses are driving us to get value out the door faster. So part of this is getting measured. Teams are getting measured on how quickly things leave the building. And so you start to see those sorts of pressures coming in, and people measuring inertia, how long is it to get things out, and how the time between, say, the earliest commit in a delivery and the time when it gets delivered. Because people are going, if I pay you to build this and it doesn't get out onto the web for a month, then that's not good, And if it's 6 months, it's really bad. And so there's all those sorts of things happening as well. And that's another drive for why this whole set of tooling is important, because the best way to make that happen is to have this fully automated, articulated solutions. Yeah.
So I guess we kind of covered safety first, Steve. I think super important, isn't it?
It is super important. I just can't tell you just how bad this is going to get unless we're in there first. The really scary point is we've all got to learn about networking and security, and the danger we have with a lot of the tools that we're talking about, Docker and all these things, is there's a whole bunch of things you have to learn to find out what their vulnerabilities are. So when you're looking at these new tools, keep that up in your mind. Go read what the vulnerabilities are and what the bad practices are in terms of security before you get too involved. Docker is a really good example of things you could do that are really good, that could go really bad.
Yeah, so things like CoreOS and both Docker and Docker as well now have vulnerability scanners built into their hubs. Yeah. So check out that kind of thing.
Yeah, and that's really cool. And that's true. That's the other thing that we're seeing is to help that, people are building services that you can buy which will scan the things you're deploying for vulnerabilities. And that's very powerful as well, because now you've got a more informed choice about how to deal with the challenges that you've got, because now you can start to see lists of vulnerabilities which have been automatically generated about the thing you're going to deploy. Yeah. And that's really cool. Yeah.
Another thing is I always mention, but OWASP. OWASP is super important. They're a consortium that sort of generates data around web vulnerability. So please do check out OWASP. Yeah. They've got this cool tool called ZAP, Z Attack Proxy, which can be used to automate certain kinds of security testing in a build pipeline. Yeah. If you also Google BDD-security, there is a BDD-style implementation over ZAP, which you can put in your pipeline. You can simulate SQL injection. You can simulate fake logins, session hijacking.
And I've got to tell you this, hacking your own system is real fun. Right? Yeah. It's so much fun, especially when you find vulnerabilities and you go back to the development teams. Go, I found this. What? Oh, yeah. It's great. I really encourage you to have a go at hacking your own systems with your boss's permission. Yeah.
Indeed. Yeah. So the final bit, hopefully we stressed this, but it is a challenge, but we need to make ops our best friends. DevOps, I think people are realizing now it's more about the culture. 2 years ago when we did this talk, it was more, people were more around the tooling. And I still get people phoning me up now saying, I want to buy a DevOps tool. And I'm like, that's probably not going to work. You've got to think about the people, the processes, optimize for feedback, optimize for learning, these kind of things. It is super important. Like Matthew's site I showed you is really valuable in terms of seeing anti-patterns. He's a consultant like me, so he gets to see a lot of these things. Seeing these anti-patterns, seeing these good patterns, make sure your team is skewing towards the good patterns. Yeah,
absolutely. You cannot deliver on what the businesses are asking you to do without engaging the people who've got the knowledge. And that's the bottom line. You need to have a better relationship with those. And I think, as we've said before with DevOps is, If you look at it, it's an extension to the Agile model. It's getting the operations guys, the guys with the important information, involved in your development processes from day one. Right? And that's really critical now because that's your new domain knowledge. We did that with Agile. We brought testers in, we brought clients in, and we're now going, next step, bring your op guys in, and they have the thing, they have all the knowledge.
Yeah, as I often see, actually, like people sometimes use Agile as an excuse to be sloppy, yeah? Or sometimes I get people saying, oh, I'm all about the last responsible moment, which is a very powerful paradigm, actually, that comes from the lean manufacturing, that kind of stuff. I defer decisions to the last responsible moment. If I don't make a decision there, it's going to be made for me. But sometimes the last responsible moment is up front. That's a really key thing. If I don't know the security, the performance characteristics that are required of my system, how can I possibly create an architecture that will meet those requirements? So sometimes the last responsible moment is up front, and that gets lost on a lot of people.
Yeah.
And I'm not trying to be too negative there, because I'm sure I was sort of started that thinking that way, but it's something I've really learned now. Certain architectural characteristics, structures of the systems and so forth, characteristics, requirements, really valuable to know up front. I think on that note, thank you very much. So we have 5 minutes for questions. We would love to take questions, actually, if people want to shout out stuff, because that would be quite good. I appreciate it's probably lunchtime soon or something. But
okay, yeah. Have 5 minutes. Okay.
Okay, so the question is, if we shouldn't have like a dedicated DevOps team, for example, and we shouldn't put it in dev, shouldn't put it in ops, where should it go? So I'm not going to explicitly answer that, because certain businesses, like classic consultant answer, it depends. Certain businesses will operate better. Some businesses don't want to have operations, for example. They're happy to bring in things externally to do that. But Matthew's website will give you some hints about the questions you need to ask for your business. Do we value operations? Well, everyone should value operations, but is it a competitive advantage for us? And what skill sets do we have in-house? That kind of thing. But Matthew's website will give you hopefully sort of an evaluation criteria and some knowledge as to what questions you should ask as well.
Well, I think that's it then.
Yeah.
Yeah. Thank you very much.
Thanks, sir. Cool.